continuously variable transmission, or CVT. CVT is a type of an automatic transmission that is commonly utilized in passenger cars. We'll go over the CVT's design and operation using a typical example. In this case, the system incorporates two variable diameter pulleys that transmit torque and can continually change gear ratio as opposed to other types of transmissions that offer a set number of gear ratios. As a result, the CVT employs optimal gear ratios. One pulley is the driving pulley, while the other is the driven pulley. Transmission between the pulleys is accomplished by the use of a special belt or chain. In this example, it is a steel belt made up of multiple links. Each pulley has two halves, one movable and one fixed, to adjust the gear ratio. The movable halves of the pulleys are propelled by supplying or draining oil from the chambers behind them. When the movable halves change their position, the belt travels toward the inner or outer radius of the pulleys. The gear ratio is determined by the difference in radius between the driven and driving pulleys. Thus, driven pulley is now rotating faster than the driving pulley. When the belt is reversed, the driven pulley rotates more slowly than the driving pulley. Proper functioning necessitates synchronized movements of the movable halves in order for the belt to stay consistently tensioned and not slip. The reverse gear requires a separate mechanism. Typically, a planetary gear is utilized for this purpose. It has one forward gear and one reverse gear. Let's have a look at this model. You can observe a simple planetary gear with a ring gear that revolves continuously while the engine is running. At that point, the force is not transmitted to the driving pulley. When the forward gear is engaged, the ring gear continues to rotate, but this also engages the sun gear, and the force is then transferred to the driving pulley. When the reverse gear is engaged, the ring gear rotates still, but the planetary carrier becomes locked, allowing the force to be further transmitted, but in the reverse direction. Here's a cross-section of the planetary gear. The engagement of the sun gear and locking of the planetary carrier occur thanks to clutch packs, which are compressed and mated with the help of pistons when pressurized oil is supplied to the chambers. Modern vehicles frequently have a planetary gear with two forward speeds, preventing the use of the most loaded extreme positions of the belt and allowing for more dependable CVT operation. The CVT can employ a number of configurations to link the engine to the transmission. The planetary gear clutch packs, for example, can also function as a wet clutch connecting the engine and the transmission. However, a separate torque converter is more commonly used. Other options are quite rare. The CVT is hydraulically regulated. A CVT valve body with solenoids responds to the electronic control unit's control signals based on sensor readings to guide oil flow to pulleys, to the planetary gear's clutch packs, and the torque converter. The required oil pressure is achieved with the help of an oil pump that pulls the oil from the sump via the oil pickup with a filter. It should be noted that the oil in hydraulic automatic transmissions gets extremely hot, owing mostly to the torque converter. The oil therefore requires a cooling system, such as a small heat exchanger, that mixes heated oil with a coolant. To clean the oil, another filter might be installed after the heat exchanger. The CVT, just like most other designs, employs a mechanical device to lock the transmission when the shift lever is in the park position. In this case, it is a parking lock gear on the CVT's driven pulley. Our review of the fundamental features of a continuously variable transmission has come to an end.